Okay, this is a problem from section 3.10. It's the section on implicit differentiation. Okay, and the question says to find the x-coordinates of the points where the tangent line is horizontal on this curve that's defined by xy equals x cubed minus 5x squared plus 2x minus 1. And they give you a picture of what it looks like. Okay, so if we're trying to find the points where the tangent line is horizontal to this curve, we need to find the places where the derivative y prime or dy dx is equal to 0. So right now we know our curve is defined by this equation, xy equals x cubed minus 5x squared plus 2x minus 1. Okay, and we want to know when is the derivative, when is y prime equal to 0. Now, unfortunately, what we have right now is the curve is defined not as y equals something. There's this equation where the x's and the y's are mixed up, so we don't have y explicitly in terms of x. Now we could find y explicitly in terms of x actually in this problem. We could divide both sides by x, and then we'd have an expression for what y is equal to. But since this is the section on implicit differentiation, let's use implicit differentiation to find the derivative. So if we find the derivative of this guy, of this equation, we want to take the derivative of both sides with respect to x. So when we do this, remember that y is a function of x. Okay, so when we take the derivative of the left-hand side, we first of all need to use the product rule because we have a product of two things, x and y. So if we use the product rule, if we take the derivative of the first guy and leave the second guy the same, we'll get y. Remember that it's a function of x. And if we leave the x part the same and we take the derivative of the y, well, remember that y is a function of x, so we get the derivative dy dx. Okay. On the right-hand side, there are no y's, so we take the derivative with respect to x, and get 3x squared minus 10x plus 2. Okay. And now what we're looking for is we're looking for the times when this derivative is equal to 0. So we want to be able to solve y equals right, because if dy dx is equal to 0, then this x times dy dx term is 0, and we just don't have it anymore. Let me write that down. Okay. So now we have y equals 3x squared minus 10x plus 2. Okay, and we need points on the curve that satisfy this equation. All right. So I guess let's look at the original equation. And let's rewrite that actually. Like I said, we would maybe try. So that was what we get if we divide both sides by x from the original equation. And so if we look at this, what we really need, if we want both that the derivative will be equal to 0 and the fact that we'll be on the original curve, we need 3x squared minus 10x plus 2 to be equal to x squared minus 5x plus 2 minus 1 over x. And we need to find the x values that satisfy this. So if we rewrite this, gathering all the terms up, we get 2x squared minus 5x. We get 2x squared minus 5x plus 1 over x equals 0. The 2's cancel on both sides. If we multiply through everything by x, let's see, we'll get 2x cubed minus 5x squared plus 1 equals 0. Okay. Let me clear a little bit more room. Let me come back up to the top. We have, what we want is 2x cubed plus 5x, minus 5x squared plus 1 equals 0. And they actually give us a hint. They say this left-hand side, this polynomial is 2x minus 1 times x squared minus 2x minus 1. That's equal to 0. So from this first term, we know x is 1/2, or x is a solution to x squared minus 2x minus 1 equals 0. And we can solve that using the quadratic equation. 2 plus or minus the square root b squared is 4 minus 4ac plus another 4 all over 2a, which is 2. So 2 plus or minus the square root of 8. So that's 1 plus or minus the square root of 2, if you do out that calculation. So at this. So we have these 3 points at 1/2, at 1 plus the square root of 2 and 1 minus the square root of 2. So if you look at the graph they actually gave you, it looks like here's a point where the tangent line is horizontal. That looks like the one at 1/2. Here's a point where the tangent line is horizontal. That must be 1 minus the square root of 2, which would be about negative 0.4. And I think here's the last point where the tangent line is horizontal, and that looks like it's 1 plus the square root of 2. So that was a good check. It seems like we got the right answer.